So hello everyone, today we're going to be doing a nice differential equation, namely y prime is equal to y to the fourth power times cosine x plus y tangent x. Okay, so the first thing we want to do is rewrite this equation in the following manner. Y prime plus p of x times y is equal to q of x times y to the n, where p of x and q of x are both some functions of x. In this example, we're going to have that y prime minus tangent x times y is equal to cosine x times y to the fourth power. Then we're going to divide both sides by y to the fourth. So y prime over y to the fourth power is equal to minus tangent x times y over y to the fourth power is the same as 1 over y to the third power is equal to cosine x. Now we're going to do z substitution, where z is also a function of x, and z is going to be 1 over y to the third power, or y to the negative third power. Now, when we differentiate this, both sides with respect to x, of course, we're going to get that z prime is equal to negative 3 times y to the power of negative 4 times y prime, which is exactly the same as negative 3 times y prime over y to the fourth power. Or when we divide both sides by 3, we'll get that y prime over y to the fourth power is equal to negative z prime over 3. Okay, with that in mind, we can now go back to this equation and we'll substitute in this and this. So here and here, right? So we'll get that negative z prime over 3 minus tangent x times z minus tangent x times z is equal to cosine x. Now, of course, we'll have to multiply both sides by negative 3. We want to have our z prime as it is. So we'll get that z prime plus 3 times tangent x times z is equal to negative 3 times cosine of x. Now we've got a first order non-homogeneous linear equation. Okay, and this is our new p of x, and this is our new q of x. Okay, so first of all, when we're solving these kinds of equations, we first have to solve its homogeneous version, namely what we have on the right side. We put that q of x is equal to 0, and then we get that dz over dx is equal to negative 3 times tangent x times z, or in other words, we get that dz over z is equal to negative 3 times tangent x dx. Now we can integrate both sides. Now, as for the first side, we'll get ln of z, or z, is equal to the 3 times the integral. Tangent x can be rewritten as sine x over cosine x, and I'll just put in the minus inside the integral sign, dx. And this is simply going to be, since the numerator is the derivative of the denominator, we can use the ln rule. This is simply going to be 3 times ln of cosine x, and I'll just add in ln c. So we can rewrite this as ln z is equal to ln of c times cosine x to the third power. Okay, so therefore z must be equal to c times the cosine of x to the third power. Now, the technique that I'm going to use is called the variation of constants, where we'll look at c not as a constant, but as a function of x. So now I'm going to differentiate both sides of this equation here with respect to x. And then I'll get that z prime is equal to c prime times cosine of x to the third power times cosine of x, everything to the third power, plus c times 3 cosine squared x times negative sine of x. So z prime is equal to c prime times cosine to the third power of x minus 3c sine x cosine squared x. Great. Now that when we've got these two values, we'll plug them in back to, not this one, we'll plug them back in to this form of our equation. So z prime, which is c prime cosine to the third power of x, minus 3c sine x cosine squared x plus 3 times tangent x times c times cosine to the third power x is equal to negative 3 times cosine of x. Okay, now let's go ahead and rewrite this in the following manner. So c prime cosine to the third power of x minus 3c times sine x times cosine squared x plus 3 times, instead of tangent x, I'll write sine x over cosine x times, c, we'll put in the c right here, times cosine to the third power x is equal to negative 3 times the cosine of x. Okay, Now, this cosine here and this square will cancel, so we'll get the exact same value as this part right here, but they're going to have different signs and they're going to cancel each other out. So what we are left with here is that c prime of cosine to the third power of x is equal to negative 3 times the cosine of x. So we can cancel out these cosines right away. Here we'll have just cosine squared. Here we'll just have 1. And we can write that dc over dx is times cosine squared x is equal to negative 3. Or, in other words, dc is equal to negative 3 over cosine squared x dx. When we integrate both sides, we'll get that c is equal to negative 3 times tangent x plus some other constant k. Okay, now when we've got the function c, we'll put it back into our solution of our homogeneous function, where we said that z is equal to c times cosine of x to the third power. So z is therefore equal to minus 3 times tangent x plus k times cosine to the third power of x. And now z is equal to tangent x, z is equal to minus 3 sine x cosine squared x plus k times cosine to the third power of x. So we've got our function of z in terms of x, but we want to find our function of y in terms of z. So when we look back at our original substitution, z is equal to 1 over y to the third power. So y, it follows from this that y is equal to the cubic root, the third root of 1 over z, which is just 1 over the cubic root of z. So finally we get that y is equal to 1 over the cubic root of k times cosine to the third power of x minus 3 sine x cosine squared x. And this is our final answer, or our function. So thank you for watching. I hope you enjoyed it. If you did, make sure to subscribe and hit that thumbs up button. I'll see you in the next